All right, chapter 11. This is the last chapter. Actually, it's not the last chapter, right? On the final, I want to remind you as I look at this one that we also did some stuff on chapter 12, which was like histograms and mean, median, and mode. So all of that stuff is on the final two. Hopefully that's fresh in your mind. If you have questions about that, just come ask me. We'll go over those things. So chapter 11, again, a little more graphing, and these problems are a little different because on these problems you have these things, if you remember, called asymptotes. All right, and the asymptotes are found. They're horizontal and vertical lines. Okay, found by thinking of what number is here. All right, on the bottom of your fraction, and what number is next to. Let me move this guy over. Plus or minus a number here. Okay. In this case, since there's no number in either one of those places, my asymptotes are x equals 0 and y equals 0. And I would always start by putting those in my problem. Okay. The graph, if this is, I'm thinking about your finals, multiple choice, it might not have those, but that's really helpful because what you know is that this kind of a graph is going to run away from these asymptotes. It's never going to touch them or cross them. Okay? So even as I start to do this problem, having that in my mind, which by the way, these are the graphs that look something like this, right? So you've got your asymptotes going through there. So I'm thinking about that as I start this problem. So when I go to set up a table and plug numbers in, I'm going to do x and y. You're going to see how that kind of works. The other thing to remember is that these work kind of like mirror images, right? So whatever happens on one side then happens on the other side. So I've got this, and we'll start with something. Again, what you recognize here is x can't be 0. Okay, I can't get 0 because I can't divide by 0. So I'm going to start with something like 1. Let's say I take the number 1 here. All right, if I plug in a 1, I end up with -2. So if I do over 1, I get -1, 2. All right, if I plug in 2, I get -1. If I plug in 2, I get -1. Okay, and again, these same values are going to be on the opposite side. So really quickly, if I plugged in, I'll just show you, if I plugged in -1, I would get +2. And if I plugged in -2, I would get +1. So everything that happens on the right side is going to happen on the left. Everything else, all the other values are going to be not nice. They're going to be fractions and decimals, and that's okay. For example, if I plugged in 3, I would get -2/3. I could still graph that. Over 3, 2/3 would be about here. Okay? If I plugged in 4, I would get -1/2. If I plug in 4, I get -1/2 right in the middle there. And you can kind of see what happens, okay, as you kind of go. I could also plug in something like 1/2. If I plug in 1/2, I end up getting, this one's not too bad, -4. If I plug in 1/2, you go down 4. Okay. So all of those values, again, if I went through and did this, if I changed this to negative, this would change to positive. So -3, 2/3, -4, 1/2, -1/2, +4. All right, and you get the idea, hopefully, of what your graph looks like. Okay. Again, a key to that, though, is these asymptotes and recognizing your graph kind of moves away from those values. All right. So this one, my asymptotes would be as follows. You would have x equals 0 and y equals 3. Quick side note, I don't know if I did one like this. Oh, I did. So if this is a negative, just to show you your asymptotes here, this would be x equals +1. Because what's going to make this a not correct problem is if this is equal to 0, right? That's what makes this not work. And so y equals 2. By the way, I didn't mention this. On all these problems, they ask us for domain range. So what's really nice is if you know the asymptotes, x cannot be that value. and the range y cannot be that value. So you can see if you find the asymptotes y equals y or x equals the domain and range, x cannot equal. Notice x will never be 0. It never goes in this place. Y will never be 0 going that way. And so you look at these two. My domain, just forgot they asked us about this. X does not equal 0. My range, y does not equal 3. Okay. And again, on this last one, domain, x does not equal 1, and range, y does not equal 2. And again, the idea is, just so we're really clear, I can't have a 0 in the denominator of a fraction. Remember, we've talked about this before. If I punched in 1 here, this would be 1 divided by 0. You punch it into your calculator, you get an error message where you can't divide by 0. And so you have these values that never work. So I would graph my asymptotes. I've got x equals 0. This is when x equals 0. And y equals 3. Okay. Notice what I did, by the way, and a lot of people do this backwards, is y equals 3. So I went up to 3 on the y-axis. And that's where my line should go through. I don't go up and down for my y lines. Okay. The rest of the time, and again, I'm not going to do number 4. I'll let you kind of figure that out. But I'll graph the asymptotes there. But the rest of the time, you're really just plugging in values for x and y. Okay. Again, I can't use 0, so I try 1. Right. I get 1, and again, maybe I'll do this again here. I'm going to do 1, and 1 plus. 1 over 1 is 1. 1 plus 3 is 4. So over 1 up 4. It's going to be right there. All right. I plug in 2, I guess. And notice what happens. If I plug in 2, I get 1/2. So this is 3.5. So 2, 3.5. All right. And again, my decimals are going to grow 1/3. So 3 and third. 3.3333. All right. Maybe even trying like 1/2. If I plug in 1/2, that's actually 2. So that's 5. All right, and I get this kind of graph here. And this way. And never crossing that line gets really close. Notice what happens if I try to change this to negative. Okay, it doesn't become -4, and this is the problem with doing it this way. This one worked out. I could just change my values because this was a really nice one. 0, 0 was kind of like the asymptotes. It doesn't work here because I added this 3. So I can't just do that. So I'd have to plug in values on the side like -1. If I plug in -1, this becomes -1 plus 3 is 2. Okay, so I get it right here. It is a mirror image, and so those values kind of work the same. If I plugged in -2, this would be 2.5. All right, if I plugged in -2, sorry, did I do it right? Yeah, 2.5. All right, 2.5. You do get that mirror image, so it is going to come this way and go down. All right. So you can keep plugging more points. These ones typically you'd have to type in a few extra values to get the a better idea of what the picture looks like. All right. Again, on this one, I just want to remind you your asymptotes x equals 1, so I go to 1 on the x-axis, put a dotted line going through there, and then I go to 2 on the y-axis, put a dotted line going through there. My graph will look something like that. Okay. I mean, those would be my asymptotes. My graph would look something like this. Okay. All right. All right. The rest of these were really simplifying. We were like adding, subtracting, multiplying, dividing polynomial rational expressions. So just wanted to remind you of something like this. I always feel like I try to do the things that are simple first. So on this one, I would reduce my, 4 and 3. I try to simplify my expressions that are simple first, that don't have addition and subtraction within them. Something I don't have to factor a ton. All right, this t squared will go away and cancel out with this t. So I've got 3 down on the bottom and 4t left on top. I'm trying to simplify those. These guys we can factor. So if I take a look at this one here, I've got t, 2t will come out, and I'm left with t plus 4. All right, and then this guy down here, this is t plus 2 times t plus 2. Okay, 2 times 2 is 2, 2 plus 2 is 4. So that's kind of the factoring thing we've done. And what happens is, again, we've seen this before, this is going to cancel out with this. So I just like to kind of make it really clear. Then I'm looking at what is left over. Got a lot going on here. So final answer left over on the top, I have 8, 4 times 2, t squared over 3 t plus 2. Okay? And I want to make sure this is clear. I'm going to do something. It's going to go away in a second, right? I can't cancel out one of these t's with this t. And then say like, oh, okay, 2 plus 3 is, or 2 times 3 is 6. I can't do that. Okay, that's terrible, right? This guy right here, I just want to make sure, the t plus 2, these guys are protected. Notice they're even in parentheses, okay? So I can't like cancel that out with something on top because it's protected. The reason I could go back earlier and cancel out the t plus 4 and the t plus... Oh, I'm sorry. This should have been t plus 2. I apologize for that. This should have been, a long time ago, this should have been a 2. If I pulled out 2t, 4t divided by 2t is 2. So maybe you were wondering why I did that. You should have been. Just kidding. So these do cancel out because they're identical. They are exactly the same. Okay. So again, sorry for my mistake earlier there. All right. This one. Again, now what I'm doing is I'm adding, okay? Difference. Multiplication, addition. Multiply, all you have to do is cross cancel and simplify, okay? At the very end, put things back together. So our final answer, like we said, is here, okay? Cover up my mistake earlier. But when you're adding, you have to have a common denominator. So to make a common denominator here, I'm going to try to figure out what do these have in common. And in this case, they don't. I know they both have k, but these are two completely different numbers. Imagine if this was 2. Let's say k was 2. This would be 3. Those don't have anything in common, right? So I have to figure out, again, how to make it so they have the same denominator. So in order to do that, I'm going to multiply this one by k over k. I'm multiplying by 1, which doesn't really change anything. So that this guy didn't have a k, now it does. And this guy doesn't have a k plus 1. So on this side I have k plus 1 over k plus 1. Okay. So on the bottom of both fractions, I'm going to have k times k plus 1, or k squared plus k. On the top, I have to do the distributive property to this guy. So I've got k squared minus 2k plus k minus 2. And then on this side, I have plus 2k squared. Okay. And then what I need to do is simplify the top. So when I'm done simplifying the top, I've got 3k squared, 2k squared plus k squared, minus k. So yeah, you got 2k plus k, and then minus 2 over k times k plus 1. All right? Now, sometimes you can factor the numerator here. You can't always. In this case, you can factor this a little bit. This would be 6, and then you would get 3 and 2. Okay. This one is a little longer, and I would be okay with this answer, but I just want to show you because this is something that I think we're not great at. Let's take this and let me factor this. Okay. I said this in another video elsewhere, but I'll say it again. If you have a number in front of k squared, you have to do an extra step when you factor. So that extra step, when you have, again, when you have a number in front of k squared or x squared, you multiply these together. So what I did at the top, you get 6. And then you think of what two numbers multiply to 6, and is there any combination that's 1 apart? So yeah, I've got 3k squared minus 3k plus k, sorry, plus 2k minus 2. And again, notice that this is the same as this. It's just another way of writing it. All right. What I would do next is group together these values and these values. I end up with 3 times k minus, sorry, I can factor out 3k. I'm left with k minus 1. And I can factor out from here a 2, and I'm left with k minus 1. So I end up with 3k plus 2. That's this guy and this guy, times k minus 1. And that's going to end up over k times k plus 1. And the only reason I would do this is to see if maybe, just maybe, these would cancel out. And that's what I would be looking for on a problem like that. Now, it didn't work out, and that's totally fine. It's still simplified. For most part, on the problems I've given you, I've accepted like this answer, just so we're really clear. I've accepted this answer before, okay? And I want you to feel comfortable giving me that. But I also want us to recognize that, yeah, you know what, you could give me this other answer that I have down on the bottom. Okay? A little different, hopefully not too crazy. Something like this, just a reminder to us really quick that when we're dividing, we're going to flip and multiply. So it should be 2t squared plus 5t minus 3 over t plus 1. Okay. Again, I would look at this and try to say, like, well, there's a lot going on. I have to factor a ton of things. But hopefully something will cancel out. And hopefully it'll cancel out pretty quickly. Okay. I want to remind you that when we do things like this, they normally are giving you a helpful hint. So this like 2t minus 1, I'm thinking that might be helpful. And this t plus 1, I'm thinking might be helpful. So if I take this big mess of stuff here, and I start to factor, there's just a lot of factoring. This guy is going to be t plus 5 and t plus 1. Okay. 1 times 5 is 5. 5 plus 1 is 6. And notice again, this is what I was talking about, them having things that are helpful. Like this is going to cancel out with this. All right. Like that's what I want. It simplifies. Okay. This guy is just what I did a second ago. So on the last one. So I just want to remind us. I do 2 times 3. Just write the whole thing over here. That's 3. So 2 times 3 is 6. I notice 2 plus 3 is 5. So I'm going to do 2t squared plus 2t plus 3t minus 3. And I want to make sure, really quick, that I got that written down right. All right. So I just want to check the original problem and make sure I copied down everything correctly. All right, so you have that, and I'm trying to think through how to factor this guy, and so I did those options, okay? And I'm looking at this and I'm like, hey, can I break this down at all? And I would say, yeah, these have something in common, and these have something in common. I'm going to run into an issue there that I don't love. So I just all of a sudden said, let me back up, let me think, are there any other numbers that multiply to 5? So notice right now these two add to 5, right? They do. There's another option here, and the other option, write it down, would be this. 6t minus 1t. Okay? Now, I don't know if you see that, right? What is 6 minus 1? Hey, that's 5. And this is actually going to work for us better. Right? That's a little trick you'd have to do. You would see that, oh, you know, things didn't work out the way I thought they were going to. I do a little grouping. Okay? Those both have a 2t, and so I'm left with t plus 3. Both of these have a negative 1, and I'm left with t plus 3. And this is what I want. I want 2t minus 1 times t plus 3. So this whole thing became 2t minus 1 times t minus or plus 3. So we're clear, the 2t minus 1 is right here and right here. Again, I've explained that better in more depth detail on other videos, so I could point you to. So notice what happened is I kind of like simplified that. All of a sudden, this thing, the 2t minus 1, and this thing are going to go away. I've got like nothing left in my denominator. All that's left on the top are these two guys, t plus 5 and t minus 5. So a whole lot of work, but it simplified a lot. All right, last thing, no, two more, three more. All right, so three more. This one is a long division problem. I'm just trying to show you the various things. There was a lot in chapter 11 that we went over. So in this problem, we're going to ask ourselves, what do I have to multiply h by to get 3h squared? That would be 3h. So I end up with 3h squared. And I multiply this to both of these guys, and I end up with plus 6h. Okay. I'm going to change my sign here so that these are going to cancel out, and I end up with negative 4h. I'm going to bring down my 1, minus 1. And then I ask myself the same question. What do I multiply h by to get negative 4h? Well, that would be negative 4. Again, I'm going to distribute that, kind of multiply that to both. So I end up with negative 4h minus 8. Again, I'm going to change my signs because I want things to cancel out, and I end up with 7. And that's a remainder. I can't do anything with that. So my final answer is the top of this, 3h minus 4. And then I got plus 7 over h plus 2. The reason we say it's a remainder is because h will never go into a number like 7. So I just leave it as a fraction. Done. Okay? This one I'm not going to solve, but I wanted to make sure, like process-wise, we remembered. All I'm going to do here is cross-multiply. So I would have 5 times x plus 1. Make sure you distribute. Equals 4 times x minus 2. Make sure you distribute. X's come to one side. Numbers go to the other side. And then you simplify. Okay? All right. Last one here is this one. And what I wanted to remind you of on this one is, if I could get all of the denominators to be the same, I could ignore all the denominators. We talked about this before with a simple example. If I have 1 over 3, let's say 2 over 3. Let's say I have 2 over 3. I can do my eraser here. It's not working. All right. All right. That worked. Weird. So if I have 2 over 3 equals x over 3, the only number that's going to make this make sense is if x is equal to 2, right? So the bottom didn't even matter, all right? So what I'm going to do is, like, I want them all to have the same denominator. The easiest way to do that is to put a 3 here and a y here and a y here. And if I do that to the bottom, I have to do it to the top. Okay? So if I can make all the bottoms the same, I'm good, and I can actually ignore all this. So now I'm just solving the top here. I've got negative 9, negative 3 times 3, plus 1y equals y squared minus 9y, distributive property here. Okay? And this problem ends up being a little longer because I have to, like, factor this, minus y, plus 9, plus 9. But it's not a crazy factoring problem because we know pretty quickly that if I have negative 1 and negative 9, then I end up with y equals 1 and 9. Okay. I would always double check to make sure those values work up here, and they do. Nothing that's wrong with those excluded y's. It doesn't make a denominator 0, and those would be my answer. All right, so it's the last one, a little longer because there's a lot more in chapter 11, just process-wise, a lot of different kinds of problems. But hopefully that's, again, helpful. Any questions you have, don't hesitate to ask, and I will help you.